This is a view of the AVEVA Dynamic Simulation software. The simulation can be opened with various roles, which determine the available functionalities and access levels. The engineer have access to the thermodynamic settings, cross-referencing, and other model design specific functions. The scenarios, malfunctions, and training performance monitoring functionality becomes available in the OTS instruction station mode. This allows operators and staff to be trained. There are also overlapping functionalities available in both roles. These functions, like custom widgets, interactive controls, and plots, are core functions for operating the model. This is a demonstration of how easy it is to build a basic model. Starting off, the components is specified, and although it's not necessary to do it as early on in the model building process, it makes it easier when you place your source that alongside the temperature and the pressure, the composition of the stream that this source will produce can already be determined. Placing a pipe is the next step, and once the pipe has been placed, it needs to be configured. The geometry is determined, and this fixes the geometry based on the diameter and length in this case, and also some of the solution options is defined. It is defined that it's only a liquid that's expected in this system, and then we follow it by placing the valve. The configuration of the valve is done also to only have liquid inside, and the CV value on the first tab is not defined, and it is left blank intentionally to be determined by the system. The source is defined as an atmospheric outlet, and then copying and pasting a pipe or any component can bring over all the pre-configured settings, and it is no need to reconfigure the pipe again. Using streams to connect the components is next, and it's a toggle switch, so once you have named your first stream, the next one is ready to be placed, and you can just cancel it by right-clicking or pressing the cancel button. Streams can easily be connected and reconnected, and then you can run your system by first initializing your system by pressing start, and then running it. Once you change your valve position, the simulation reacts on that. As you can see, the CV of the valve has been calculated, and therefore it was not necessary to define it if you do not know the CV value. Adding onto the simulation is very easy. You can just disconnect the stream, select the component that you want to add, do the configuration of the component, and reconnect your stream. You can select more process streams and you can copy and paste existing components, and then just ensure that all the geometry and the configuration on the copied and pasted items are the same. In this case, the stream is copied and pasted to show that you can do that as well. It's neatened up by removing a section of the stream, and then some new streams are added into the system. Once the system is ready, it's reinitialized, and once it has initialized, it is run again. Here you can see the effect of opening a valve on the tank liquid level. There, the liquid level determined or shown by L is shown how it decreases in value, as well as the percentage indicator on the tank. To change the conditions again, the outlet is closed and the inlet is opened, just to show that the valve can open up, can fill up as the system goes on. That is a basic demonstration of how easy it is to use the simulate to build a simulation. This is a more complex model of a tank farm. Currently, it's not initialized, and all the inputs are showing the default -999, and also the valves is gray. Initializing the model will pre-populate the outputs with the status of that equipment piece, as well as change the color on the valves, for example, and also indicate the zero inventory in the tanks. The view can be changed to view the whole system, or even to view only a page zoom in level. If you want to have more granular view change, you can also use a small increment to zoom out, as well as a small increment to zoom back in. Currently, there's no inventory loaded, and the initial condition can be defined and then also load in when you start your model. As you will see, the tanks now have an inventory, and then also the status of the equipment is defined. If we want to change the valve's input there, you can see it changes from a red to a yellow color, and then once it's fully open, it changes green. If we start the pumps, you will see that manipulated variable, or the flow rate in that stream, changing from 0 to a different value. We can add a trend for that value as well by copying the name and then just adding a trend object, putting it on the worksheet, giving it a name. And now once you are in the plot trend window, you can paste that name and it will start draw the trend of that specific process variable, and you can see the change over time. As you see, it's quite a slow process, so we want to increase the speed so that it just shows the change in the process dynamics a lot faster. And there you can also see that the rate at which the line is being filled in is a lot faster. Looking at the trend window for the PID controller at the inlet of the next tank farm, we can see that it changes along with the process conditions as it changes. We can change the set point of that specific PID controller, and once we change it, we can open up the trend window again, and we can see how the process reacts to this specific change. As you can see, it is still changing as the process changes, but it is converging to a new steady state. Closing this window, it is also possible to trip a pump or trip equipment. As you can see, once I click the trip button, the red pump or the third pump from the top became red, and also the small M that was at the top right of the pump changed from an amber color to a red. This is one of the functionalities that Dynamic Simulation offers, where you can induce malfunctions into your system to assist in the training of operators. Thank you for the opportunity to tell you about AVEVA's Dynamic Simulation. I would love the opportunity to tell you about the other products, AVEVA Pro 2 Simulation and AVEVA Process Simulation, and how they integrate with AVEVA Unified Engineering and some of our other very exciting products. Please join me for an in-person demonstration at our Customer Experience Center, which is located at our offices in Midrand. For more information on any of these products, please don't hesitate to contact us or visit our website at is3.co.za for more information. I'm Louis Hugo, and thank you for the opportunity to tell you about AVEVA Dynamic Simulation, and thank you for taking the time to watch this webinar. I hope to catch you in the next episode of the X-Celerate webinar series. Have a good day.